Welcome back. Today, part 2 of our Mitsubishi Delica cylinder head job. So last week, we removed the cylinder head, we removed the timing belt, and this week, we're going to strip down that original cylinder head, make sure the components are in good condition, and we're going to reinstall them on the new cylinder head, sitting here, waiting ready to go. So before we start taking apart the old cylinder head, there's a few things that we should go over about the new head. First off, there's two different variations of cylinder head. Second, there's two types of head that you can buy, in that one is bare or one is completely preloaded. So the one that we're going to be working with today is the bare head. No camshaft, no valve train, it's got nothing in it at all, just bare. However, if you don't want to tackle switching all of the parts over, you don't have the time, you can buy one that's preloaded. The preloaded heads can be a real time saver, but they do cost a little bit more. There are a few things that you should be aware of though if you are going to buy a preloaded head. Not all of these are the same quality. Most of these heads come from overseas. Some of them are pretty bad reproductions. Check the bearings on the rocker. A lot of the lower quality units have a bearing that's about half the size of the original, and I've seen them eat into the camshaft and basically take the engine out within a few months of installation. So make sure that you're getting a decent quality head if you are getting it from overseas, otherwise try buying an OEM Mitsubishi or a Hyundai head. Now this brings us to the second part. You need to know which head are you actually buying. There are two different variations. There's a protruding valve and a flush valve, or an early and a late head. The late model heads have a flush valve. The early stick out. Now, why is this a problem? Well, if you use a late head, it's not a problem. You can put a late head onto an early block or a late block without an issue. However, if you go the other way around and you put an early head onto a late block, you're going to end up with piston to valve contact. So make sure that you buy the right head for the block. If you're looking at your head and you're not sure which one you have, it's simple enough to take a straight edge and just place it on top of one of the valves. If you can rock it back and forth, you have a protruding valve. If it sits flat, you have a flush valve. Now that we've confirmed that we do have the right cylinder head to replace this with, we can start dismantling the old one. So I'm going to start by taking out the fuel injectors. It's probably better to do this with hand tools, but I'm going to use the electric impact. Be very careful when removing the return. It can be a little bit sticky, and if you force it, you can break it. Once those are up, we can take out the glow plugs. These ones I highly recommend using a ratchet on if you haven't been out before. I know these ones have only been in there a short amount of time. They were anti-seize when they were put in. So again, I'm going to stick to this just to save some time. If you're finding your van has a hard start on cold days or smokes or runs rough, it might be advisable to replace the glow plugs anyways. If you do replace them, go with OEM Mitsubishi. The NGK ones just don't work quite as well. So with all of our peripherals out of the way, now we can take out the valves. You're gonna need something like this. Valve spring compressor. They can be bought pretty cheap online or at your local auto parts store. I have in the past had success just putting a socket on top and giving it a quick wrap to get the retainers out. Not the best way to do it, and it doesn't help you at all when you need to reassemble, so inevitably you're gonna have to have one of these anyways. Having a magnet makes it way easier. Watch for that. So that's it. Our old cylinder head is stripped. We're ready to check these parts, make sure they're in good condition, clean them, and then we can reinstall them in the new head. This part is completely unnecessary, but I do it just for the sake of doing it. Alright, what I'm doing right now is absolutely unnecessary. You don't need to do this. I just do it because I do it on all of my cylinder heads. Does it do anything? I don't know. It just makes me feel better. The factory castings on these heads are not exactly all that smooth. If we look inside this intake port here, you can see there's a very sharp lip here. There's a very sharp lip on the top as well. Now, I won't be able to see it very well, but you will be able to hear the difference. You can hear the threads catching on the edge there. This cylinder here has been smoothed out already. So the basic idea behind this is when you have a big lip like that, it's not exactly that great for flow. So by removing the lip, I'm trying to improve the airflow into the cylinder and give it something to actually follow and flow past the valve, hopefully a little bit smoother. So I have done this on most of my cylinder heads I put in the Delica. Like I said, it's hard to say whether it makes a huge difference or not because these vans are gutless to begin with, but my vehicles can cruise around at 130 kilometers an hour while fully loaded, so I figured that's not too bad. For the little bit of time it takes, I think it's worth doing, at least for myself, but honestly, it's really not necessary. Now that I got everything cleaned up, we can take a look at the valves and springs and the rest of the components to make sure everything is in good shape. I don't see any pitting or damage on any of these valves, so I'm not too concerned about reusing them. And also, they are an OEM valve, even though these are Hyundai, not Mitsubishi. I feel much more comfortable using those as to the offshore valves. Valve springs, again, these are OEM valve springs, but Mitsubishi's spec states that they should not be below 48.1 millimeters when relaxed. I'm getting 47.2. And according to Mitsubishi, that means that these need to be replaced. So I figured I would pull the valves out of a couple of other cylinder heads I have here, including the brand new one, and another old cylinder head I had kicking around. The new one measured out exactly the same, as did the valve springs off the old used head that I had kicking around here. And that head didn't have very much use on it. It is one of the ones that ate the camshaft that I was talking about before. And that's when I noticed something very different. The spring rate on the head that ate the camshaft is substantially higher. When I punch these numbers, these specs, into a spring rate calculator, the OEM comes up at about 12 point something Newton meters, whereas this aftermarket offshore one comes up at just a shade over 20 Newton meters, so it's substantially stiffer. I don't know if this is definitely the cause, but I suspect it has a good part to do with the damage that you see on this cam. You can see how the rockers have actually eaten right into the camshaft, and this is actually the second cam that head did it to. The original cam, it did it to almost immediately, and I thought maybe that has to do with not enough zinc additive in the oil I was using. So this is an OEM Mitsubishi cam, and used, so it shouldn't need a zinc additive. But even with the zinc additive, it ate the camshaft as well. So again, something to keep in mind if you're buying a fully loaded head from China. Take a look at the valve springs too. If they don't match, it might be a little bit of a risk. First thing we're going to install is the valve stem seals. They're positioned right on top of the valve stem guide, and as the name indicates, they seal the valve, and their job is simply to prevent any oil from coming down the valve stem and into the combustion chamber, where it'll burn blue when you turn the vehicle on. If you do find that you're getting blue smoke on startup, which goes away quite quickly, or the vehicle's been sitting a while and you start it and it smokes blue, quite often it's the valve stem seals that are bad, so they might need replacing. This one here is an old one, so we're not going to use that. The new valve stem seals, make sure that you've lubricated everything thoroughly before trying to install it. I just use 1030, just in my little Tostitos thing here. Put it around the guide and on the inside of the valve stem seal as well. Then to install it, there's a special tool. I don't own it. So an 11mm socket fits quite nicely on the outer diameter of the valve stem seal. Ideally, we'd be able to push these things straight on. But using a socket, that can be very difficult. You might find that the seal tries to walk right, left, back, forward. If you force it, you'll damage it, and you'll end up with the blue smoke that we were just talking about. That seal needs to go on as straight as possible. So get it on as far as you can by hand, make sure it's straight, and then some gentle taps with the mallet should finish it off. That's it. With all of our seals in place, we can look at actually moving on to installing the valves themselves. There's a coating that's on all of the heads when you get them out of the box. Now's a good time to just remove some of it. Brake clean takes it off quite nicely. Same as with the valve stems. Make sure you oil the valve before installing it. The valves should slide in freely. If you find that there's any resistance or notchiness, there's something wrong. So you need to take a look, see if you've got maybe a bent valve, a damaged guide, or anything that might be interfering with the valve's ability to move freely. We can carefully flip the cylinder head back down onto its face, and we can install the valve springs. I know these are technically below spec, but because all of the other cylinder heads I measured, including the brand new ones, came up the same, I'm going to reuse these ones anyway. I might get some on order later on and measure them, see if they are different. If they're bigger, I'll just swap them when they're in the vehicle. But for now, I think it'll be just fine. And honestly, these motors don't really rev that high anyway, so I'm not too concerned about it being an issue. When installing, painted side should face up. So now we can remove the cam towers and install the cam. The first tower has no markings on it, but each consecutive one after will be labeled 2, 3, and 4. The final one doesn't have any marking. Make sure that these go back in the exact same order. If you put them in a different order, you do risk damaging the camshaft or ruining the head. These are bolted down, and then the camshaft hole is bored through. So if you mix them up, the holes won't line up properly, and you could end up with binding on the cam. Once the bolts are spun down, we can go ahead and torque them down to 20 Newton meters or 14 foot-pounds. Now we can flip to the front of the cylinder head, and I would recommend putting this piece on at this point because it's a lot more awkward to do it after. Next, we can put in the front cam seal. Again, lube it up on the inside with some oil, and I put a little bit around the outside too, just to make it a little bit easier to install. Place the seal over the cam, and there is a special tool to install it. Obviously I don't have one, but you can get away by using a 36mm socket. What you're looking for is the seal to be about flush with the inside of the chamfer on the inside sealing surface. I'm not going to install this yet. Trying to install on the bench is extremely difficult. The head moves around a whole lot, so we'll install that once it's on the engine block. In the meantime, before we put on the rocket shaft, I want to try get some of these peripherals in first. Most of the heads do come with a piece to go in here. The problem is they don't have this bolt hole for you to be able to mount your dipstick. So you'll need to save this off of your old cylinder head. You can use liquid sealant here or tape. Remember, if you're using tape, to spin it on in the correct direction so that as you're tightening it into the hole, it's trying to tighten the tape onto the threads as opposed to peeling them off. It should be tightened so the port's facing the back. That's about it for the valve train. I've installed the rocker shaft, but I haven't tightened it down yet. We'll do that after, because once you tighten it down, it's going to open the valves up. And because we're sitting on the table right now, obviously, I don't want all the weight resting on the valves. So that'll be the last thing we do, tighten it down before it gets installed in the engine. In the meantime, we can finish installing all of the studs, the turbo feed, the injectors, and our glow plugs. That's about it for the cylinder head, other than torquing down the rocker shaft, which we'll wait to do because I don't want those valves sticking out and resting on the bench. All that's left now is to prep the block and get it ready for the cylinder head. With our cylinder head all assembled and pretty much ready to go, save for a couple of bolts left to tighten down, we can now move on to the block. And that means we need to get the surface prepped for the head gasket. That involves cleaning it, smoothing it out, and before we can do that, removing the dowel pins. The dowel pins in this motor are pretty seized in there, so I'm going to show you a technique that you can use to get out even some of the most stubborn dowel pins. Here's what we're working with. As you can see, there's already some damage on this dowel pin. We've got one in the front and one way back here in the back. The right way to take these out would be with a dowel pin puller, but it's a special tool. Unless you're a machine shop or an engine builder, you likely aren't going to have one. So most likely you're going to be trying to use something like that, jamming it on there and trying to twist it out. And what you're likely going to find is this circle becomes an oval really fast. So what I've got here is a drill bit, and it's approximately the same ID as our dowel pin. Remember, a hammer is the closest tool to you. We're going to tap it in there and making sure that we grab it on the flutes. Going to vice grip as tight as we can on it. Having the drill bit in there is going to prevent the dowel pin from collapsing and allow us to get a decent amount of pressure on it. And then we're just going to slowly walk it out. Just make sure when you clamp this on that your vice grip isn't touching the block. You don't want to scratch up this surface.
that's what we're left with. Small marks from the jaws of the vice grip, but nothing too major, and nothing that a file won't take care of. So if you can replace these, obviously it's better. I don't have new ones, so I'm just gonna reuse these. That means we can get on to prepping the block. With this. Not with this. No, a lot of people do use this. I used to use it as well. There is a better way to prep the block surface though. Even though this gets it nice and shiny, it does not get it flat. And obviously, for a sealing surface, flat and flush, that's what we're going for. So we're going to use scraper, sanding block, and some WD-40. And that's all there is to it. So our block is now sanded down smooth, it's prepped, it's clean. All that's left is to put the dowel pins back in and we can start reassembly. I know this thing does take a long time. There are faster ways to do it. Some people will say use the die grinder, and if you insist on using the die grinder, then at least use one of these little plastic wheels. There's a very, very low possibility of digging into the metal with this, but it does do a good job of getting everything clean. This is just my preference. Once you're done sanding it down, give it a good spray with brake clean or carb cleaner and keep wiping it until there's no more dirt coming off on your rag and you're ready to go. So that's about it for today. Tune in part 3 when we'll reassemble. See you then.